Equipping your new driver. Module 4, Adjusting Speed. This session is designed to help drivers make better decisions concerning how fast they should drive. 4 concepts are presented. They are: 1. Visibility and speed. What you can and can't see should influence your choice of speed. 2. Surface conditions and speed. How traction limitations affect safe travel. 3. Traffic and speed. How traffic conditions determine safe travel speed. 4. Crashes and speed. In a variety of cases, to drive safely, drivers have to adjust their speed to well below the posted speed limit. The principle detailed in each segment provides the best information concerning the choice of speed, not speed limit signs. Segment 1, Visibility and Speed, will address the identification of a 4 to 5 second stopping zone, also known as your immediate path of travel. Emphasis is placed on the concept that what you can't see can hurt you.
How fast is too fast? 35, 45, 55? What's the answer? Obviously, there isn't any one answer. It depends upon conditions. In conditions like this, any of those speeds would be too fast. Out here, 55 would be a bit slow. Of course, few of us get the chance to drive under conditions like these. We have to share the road with lots of cars, often under road conditions that no racing driver ever has to contend with. And you can't tell what you're going to find in the road ahead. These are the things we will be talking about: how to adjust your speed to visibility, to road conditions, and to other traffic. How fast can you safely drive here? Straight road, dry surface, good visibility. Not another car moving. Oops, didn't see him. Would you have been able to stop in time? If you were traveling 55 miles per hour, your total stopping distance would be well over 200 feet. That's about 150 feet beyond the car. You can have the best brakes and the greatest reaction time in the world, but first, you have to identify the problem. So at 55 miles per hour, it will take over 200 feet to stop. What if you're going only 45 miles per hour? Better, but not good enough. In fact, if you were going any faster than 35 miles per hour when you first saw this car, you couldn't keep from hitting it. That's right, the car's about 100 feet away, and that's about the distance it takes to stop at 35 miles per hour. It takes a while to get up to 40 or 50 miles an hour, and it takes a while to stop. At highway speeds under normal driving conditions, it's best to allow up to 4 seconds to bring your car to a full stop. It's not exact, but it's a good rule of thumb. But what does this have to do with visibility? Just this: if you don't have a clear view at least 4 seconds ahead, you're going to have trouble stopping in time to avoid something that enters your path. Here's another place that the 4-second rule applies. You have no idea what's over the top of the hill. It could be this: the top of a hill should be approached slowly enough to let you see at least 4 seconds ahead. And remember, your stopping distance increases when you're traveling downhill. Fog is responsible for many fatal collisions. It can be very deceiving. Drivers find that they can see the road fairly well, so they keep cruising right along. The trouble is that while they can see the road fairly well, they can't see what's ahead of them. If there's a car moving slowly or stopped in their path, they won't see it until it's too late. If they crash, there's a good chance another car will crash into them. Sometimes a dozen or more cars are involved in such chain reaction crashes. When you're driving in fog, snow, or heavy rain, you can use the 4-second rule to check your speed the same way you use the 20-second rule to check your seeing habits. When you first make out an object like that parked truck on your left, start counting: 1001, 1002, 1003, 1004. If you reach the object before you get to 1004, you're going too fast to react to anything that might enter the path ahead. Here's a familiar scene. What would you consider to be the most dangerous thing about that bus? It may pull out, it's partly in your lane, or it obscures your view.
It's true, the bus is partly in your lane and it could pull out. However, the major problem is the bus obscuring your vision, and what you can't see can hurt you. Since the bus is partly in your travel lane, pedestrians may assume that the lane is blocked and dash into the street. Drivers entering the roadway from the right may make the same assumption. It is essential when moving at highway speed that you remember your immediate path of travel, the distance required to stop, is a zone extending 4 to 5 seconds ahead of your vehicle. In effect, you must respond to a stationary or crossing hazard at least 4 to 5 seconds in advance of encountering it. Remember that parked or stopped vehicles, hill crests, curves, shrubbery, buildings, or objects within your own vehicle can reduce the distance you can see ahead. Throughout the program, following each discussion slide, there will be a short quiz of 1 to 3 items covering the concept presented. The quiz is multiple choice. After the question is read, select the best answer. A discussion of the correct answers will be provided at the end of each module. 1. The time a driver needs to stop from a speed of 55 miles per hour to avoid hitting a fixed object in the roadway is approximately A. 2 seconds, B. 4 seconds, C. 8 seconds, D. 12 seconds. 2. Proper speed adjustment will provide A. Time, B. Distance, C. Visibility, D. All of the above. 3. You should always choose a speed so that the distance you can see ahead along your path of travel is never less than A. 2 seconds away, B. 4 seconds away, C. 8 seconds away, D. 12 seconds away. Even if visibility is good, available traction should influence a driver's choice of speed. The next segment deals with road conditions and speed selection, hydroplaning or aquaplaning, wet ice, and ice found on bridges.
This is what really controls your speed. Your tires have about a square foot of rubber in contact with the pavement. This square foot has to move, turn, and stop 1 to 2 tons of automobile. To do this, each of your tires has to have a good grip on the road. When weather conditions make the road surface slippery, your tires begin to lose their grip. Wet pavement can reduce your tire's grip by as much as 30%. That's about the amount you'll have to reduce your speed in order to maintain the tire's grip. It's amazing how many people don't recognize this. They cruise right along at the same speed that they would on dry pavement. They do all right until something goes wrong. Pavement is likely to be most slippery just after the rain has started. The first drops mix with oil on the surface. The combination of an asphalt surface and a hot day makes for a particularly slick surface. Watch out for places where water has collected on the surface. At moderate speeds, such as 35 miles an hour, tires with good tread will wipe the water off the pavement. At faster speeds, the tires begin to ride up on a film of water. They actually lose contact with the pavement. This is known as hydroplaning. When your car hydroplanes, you have about as much control as you do on glare ice. Many people have trouble believing their tires can actually lose contact with the surface until it happens to them. And it happens often enough that highway engineers have started cutting grooves in the surface to prevent hydroplaning. But where the pavement isn't grooved and water does collect, the only way to keep from hydroplaning is to drive at a moderate speed. Unfortunately, it's hard to tell when you're hydroplaning. Your first cue is the sight of water on the surface. If you wait for a cue from your car, it'll be too late. Nobody needs to be told that snow and ice are slippery. Yet those of you who have driven on it for years know that it is something to be respected rather than feared. For those of you with less experience, here are a few suggestions. Do things gradually. Avoid trying to make quick turns or trying to stop quickly. Of course, you can't do things gradually if you drive too fast or have to make last-minute maneuvers. The secret is to operate at a slow, steady speed and to anticipate changes well in advance. Something else to remember is that snow and ice are slipperiest when they are melting. Your tires have only about a third as much grip on melting snow or ice as they do on dry pavement. Under conditions like these, you'd better reduce your speed by about a third. It's also a good idea to see how much grip you really have. The same thing is called for if it snows before the ground has a chance to freeze. It's not always easy to tell when the road is going to be slippery. In this situation, there is a bridge where the road dips. Would you expect freezing to occur first on the bridge, at the bottom of the hill, or on the curve?
If you said on the bridge, you're right. Since heat from the earth does not keep the bridge surface warm, the temperature of the bridge changes much more rapidly than the road surface and freezes more quickly. It might be slippery at the bottom of the hill, particularly if it's in the shade, or if there's an intersection close by where exhaust from idling cars, melting snow or ice might be built up. But the most hazardous spot is the bridge. Anytime you approach a bridge during the winter, avoid braking or accelerating while on the bridge surface. 4. When driving on wet, snowy, or icy roads, you should A. Drive at the same speed as if the road was dry. B. Drive at the same speed as other traffic. C. Reduce your speed to meet road conditions. D. Reduce your speed by 5 miles per hour. 5. When raining, the road will be most slippery. A. Just after it starts to rain. B. After it has been raining a few hours. C. After it has stopped raining. D. Only if it is a heavy downpour. 6. The best way to prevent hydroplaning is to A. Have good tires and drive at a moderate speed. B. Pump your brakes when slowing down. C. Increase speed slightly to test for traction. D. Drive in the right portion of the right-hand lane. In the next segment, we will discuss how other drivers affect your choice of speed. Included are the problems associated with speed faster or slower than at which traffic is traveling, speed and collision potential, lane width, position within lane, the off-road environment, and speed zoning.
Traffic. You can't avoid it. It can turn an expressway into a parking lot. The 55-mile-per-hour limit doesn't cramp anyone's style here. Traffic conditions play a big part in deciding how fast you can travel safely. Traffic wouldn't be a problem if everybody drove at the same speed. Drivers going in the same direction at the same speed don't run into one another. But cars travel at different speeds. They constantly change lanes, overtake, and pass one another. This is when collisions happen. The heavier the traffic, the greater the chance of a crash. There's not much you can do to get drivers to operate at the same speed, but you can make things easier on yourself by adjusting your speed to that of traffic in general. Statistics show that the safest speed to travel is the prevailing speed of traffic. A lot of drivers don't know this, or they don't believe it. Recognize this guy? Right. It's Macho Max, your classic speed freak. No matter how fast traffic is going, it's too slow for him. He has to squeak through every hole he sees. One unexpected move by another car, and it's curtains. And what does Macho Max get for his troubles? Studies have shown, time after time, that all he can save by pressing his luck is about 5 minutes in every hour. What can he do in those 5 minutes that make them worth all the hassle and the wear and tear on people's nerves? Another way of keeping pace with traffic is to pick a lane in which traffic is going the same speed you are. Experienced drivers generally know what the various travel lanes are intended for, yet many of them end up in the wrong lane. Like Shaky Cheryl here. And it could just as well be Shaky Hal, doing about 10 miles an hour under the speed limit. What's she doing in the left lane? People who are unsure of themselves often hug the left side, where they can see the edge of the road better. The trouble is that while they get a good look at the edge of the road, they have a hard time seeing cars overtaking and passing them on their blind side. The place for slower-moving cars is usually on the right, where other drivers expect them. Lazy Larry here cruises in the left lane just to save himself the trouble of having to change lanes if he comes up on another car. He thinks it's all right as long as he's driving close to the speed limit. The point is, if any drivers are going the speed limit, Larry forces them to pass on the right side where he can't see them. The left lane isn't always the fastest. Hurry Up Harry doesn't seem to understand that, or else he's not paying attention. He pulls into the left lane, manages to pass a few cars, and then gets trapped. Once he gets free, it's right back into the left lane and stuck again. The right lane can be almost as bad because of cars turning on and off the highway. Here's a driver overtaking a truck on a long grade. He can do one of two things. He can cruise right along until he gets behind the truck, then slow down and wait for a chance to change lanes. Or he can recognize that a truck near the top of a long grade is probably going pretty slow, and he can start changing lanes now. That brings up another way of adjusting speed to traffic. Some people seem to smooth out the wrinkles in traffic by anticipating what's going to happen and being able to make changes gradually and smoothly, while others make things worse by reacting at the last minute. In this situation, the smoother outer will slow down gradually, letting drivers behind do the same. Everyone gets a chance to readjust gradually. On the other hand, the driver who doesn't do anything until the car ahead stops is likely to set off a chain reaction. He'll have to stop quickly. The driver behind him will have to stop more quickly, and the driver 2 cars back even more quickly, and so on. Remember, the purpose in looking at least 20 seconds ahead is to be able to respond to situations early. How should you react to this situation? Begin to slow down. Begin a lane change. Maintain your speed and direction.
By looking 20 to 30 seconds ahead, you can better anticipate the actions of vehicles leaving or entering traffic, and if possible, move over to give the drivers an opportunity to make their maneuver more smoothly. Slowing abruptly may confuse or anger following vehicles. If a lane change is not possible, try to maintain speed and lane position so that the vehicle can enter in front or behind you. If possible, when driving on a freeway, adjust your speed to avoid traveling in a pack of traffic. If you have cruise control, an easy way to achieve this is to accelerate to the speed of traffic, then reduce your speed by approximately 2 to 3 miles per hour and set the cruise control. 7. Selecting the appropriate speed of travel depends upon A. Visibility, B. Road conditions, C. Traffic conditions, D. All of the above. 8. Merging situations involve maneuvers in which A. One driver should adjust speed and lateral position to a second car, B. One driver should yield to another, C. One driver should change lanes to avoid the other, D. Both drivers should adjust speed and lateral position. Segment 4, Collisions and Speed. The last segment of this session is called Collision and Speed. Its attention is directed to the influence of speed on merging, diverging, traveling up and down grades, and the idea of speed zoning.
By making what's known as a complementary lane change, you're helping to keep traffic flowing smoothly. The driver coming down the on-ramp also helps by entering at highway speed. Not everyone does this. Remember him? It's going to take him at least 10 seconds to get up to highway speed from a standing start. To enter safely, he's going to need a gap in traffic of about 800 feet. He probably won't get it. When he gets tired of waiting, he'll just pull out and force another driver to hit the brakes or make a sudden lane change. Driving too slowly can be just as dangerous as driving too fast. You have to keep moving in order to keep pace with traffic. This principle sounds simple, but it's surprising how many reasons drivers can find for violating it. Here's one. Because the off-ramp's a little on the short side, this driver is starting to slow down on the main highway. It's really asking for trouble. As long as he's on the highway, he should keep moving at highway speed. True, he'll have to use his brakes once he pulls into the exit lane, but that's a lot safer than slowing down out here. There are some situations where it's impossible to avoid slowing down. However, the principle still applies. Maintain as much speed as possible. Some drivers come almost to a stop. The driver behind doesn't expect it and often doesn't recognize it until too late. Some drivers will move around a corner all right, but then they stop to figure out where they want to be. This is likely to catch a following driver by surprise. Even if the other driver does stop in time, the back of his car is still in the travel lane. If there are other drivers who want to turn into the shopping center, they are forced to come to a stop on the highway. Anytime you pull into a shopping center, keep moving until you are well clear of the entrance. That's time enough to decide where you want to be. Keeping pace, selecting the right lane, anticipating changes, and keeping things moving are ways of maintaining a smooth traffic flow. It not only makes things easier for other drivers, but lessens your chance of being hit from behind. Yet there are times when a smooth flow of traffic is out of the question. It's just a matter of reacting quickly. Which brings us to the final principle. You need time to react, time to steer out of trouble or bring the car to a stop. The slower you are driving, the more time you will have. It wasn't so long ago that you could maintain a pretty steady 50 miles per hour on this road. The road itself hasn't changed much, but the businesses that have sprung up along it, cars entering, leaving, and crossing it, well, you'd have to be crazy to drive at that speed today. In short, how fast you can drive is determined as much by traffic along the side of the road as by traffic in it. Handling this problem is the hardest job of all, since it means adjusting your speed to what might happen rather than what is happening. Places where you need to allow yourself time to react include school zones, playgrounds, and shopping centers, construction areas where workmen and equipment are moving back and forth. Unfortunately, there are a lot of drivers who don't allow time to react to the unexpected. They set their speed only by what they can see. If they can't see a problem, they just open up and go until they can't. Now, let's review the things that determine how fast you can safely drive. There's visibility, how far you can see. There's the roadway and the kind of grip your tires have. There's traffic, the need to keep pace with it and to find the right lane to travel in, to anticipate changes, and to keep moving. There's one thing we haven't discussed. It's the first thing that some people think of when the subject of speed comes up. It's the whole question of speed zoning. There's a reason why we haven't discussed speed limits. The reason is that speed limits don't determine how fast you can safely travel. There's a connection, all right, but it's the other way around. How fast you can safely travel is what determines the speed limit. When traffic engineers post limits, they consider such things as visibility, what the road is like, and how much traffic there usually is. From these things, they decide how fast you can safely drive. Drivers who do all these things for themselves can do just as good a job of setting speed limits as traffic engineers. In fact, they can do an even better job since they can change their limits when conditions change. The truck driver was driving at the posted speed limit when the driver ahead pulled out to pass, decided he didn't have enough room, and pulled back in front of the truck. The truck driver hit his brakes, spun out, and rolled over. Was he driving safely and had bad luck? Driving unsafely, but within the law? Driving in violation of the law?
There's no such thing as bad luck when driving. The driver of the truck should have realized that as a result of the car's speed and position, it was going to have to pull back into the lane. In short, the truck driver was driving unsafely and violated the space in front of his vehicle by not maintaining an adequate gap to allow for the behavior of the other driver. It is also possible that he was violating the law in that while he might not have been driving recklessly, he was following too closely. 9. The safest speed to travel on the highway is A. At the posted speed limit, B. A little slower than other traffic, C. The same speed as other traffic, D. Within 10 miles per hour of other traffic. 10. A deceleration lane on a freeway allows drivers to A. Reduce speed before entering the off-ramp, B. Make last-minute decisions on whether or not to exit, C. Pass slow-moving vehicles when the freeway is congested, D. Stop in case of emergency.
You may have heard it said that speed kills. This isn't really true. The only thing that speed by itself kills is your gas mileage. You burn almost 30% more gas at 70 than you do at 55. What really kills people is failing to adjust speed to conditions. It's the surrounding conditions that determine how fast you can safely drive. Like how far ahead we can see. It takes us 4 to 5 seconds to stop a car. This means we've got to be able to see the road and anything that may enter it at least 4 seconds ahead. If we can't, we've got to slow down until we can see 4 seconds ahead. The surface of the road is a factor. Our tires need a good grip to be able to turn or stop our car quickly. Rain reduces our tires' grip by as much as a third. Snow and ice reduce it by as much as 2/3. Speed must be reduced under these conditions if our tires are to maintain their grip. But the most important factor of all is traffic. Most accidents result from interruptions in the flow of traffic. Interruptions caused by people who are driving faster or slower than the prevailing speed. We can all help keep a smooth flow of traffic by keeping pace with other cars, by driving in the lane of traffic that corresponds to the speed we want to travel, by avoiding sudden speed changes, and anticipating the speed changes of other drivers. Knowing that traffic doesn't always flow smoothly, we can slow down where interruptions are most likely to occur and give ourselves more time to react. In short, safety isn't a matter of how fast or slow we drive, but how well we adjust.
We will now review the questions. 1. The correct answer is B. When traveling at 55 miles per hour, taking into consideration the time required to perceive a potential problem, to react and then brake to a stop requires approximately 4 seconds. 2. The correct answer is D. Regardless of the posted speed limit, a safe speed to travel is always dependent upon visibility, traction, the ability to maintain distance between one's own vehicle and other roadway users, and the time available to perform an evasive maneuver if required. 3.